Hey guys, how you doing? This is Miss Gibbs, and I just wanted to take an opportunity to help you prepare for any retakes that might be necessary on the Unit 4 equations test. In particular, this is being done for extended students. Okay, let's begin. Which is the solution to negative 7c plus 2 equals 16? Well, let's take our handy dandy little pen, and we should remember that we need to unwrap the gift. You remember me talking about that? In other words, undo PEMDAS in reverse order and do the opposite operation. So if I knew what C was, I would multiply it by negative 7 first and then add 2 to that product. But since I don't, then I need to subtract 2 from both sides of the equation. So I'm going to subtract 2 there, subtract 2 on the right, and then I'm going to tally up, and I have now canceled or created a zero pair between positive 2 and negative 2. So all that I have left is negative 7c. Trying to get that variable alone so that I can find out what it's equal to. And so negative c equals 16 minus 2, or we could say 16 plus a negative 2. Either way, if you type it into your calculator, you'll get 14. Next, since I've undone the addition, next I need to undo the division by dividing both sides, multiplication by dividing both sides of the equation by the coefficient of c. The entire thing must go. That means divide both sides by negative 7. Divide 14 as well by negative 7. Okay, and now once we do that, negative 7 divided by negative 7 actually equals 1 according to our multiplicative inverse property, and then 14, so this leaves c, and then 14 divided by negative 7 leaves us with negative 2. I like to remind you that we process our signs first. A positive divided by a negative leaves a negative, and then process your numbers. 14 divided by 7 leaves 2. Put them together and you've got C equals negative 2. So D is the answer here. If these questions look familiar, it's because this is the actual test that you took a while ago. Okay, so let's move down to number 2. Guess I need to find my eraser and get rid of all of this and start again. Number 2 says solve for m, where m minus 1 is being divided by 2, and that equals 6. See if I can change this pen color. Oh, purple. Cute. Let's see. Okay, so m minus 1, I'm going to rewrite it first. M minus 1. That quantity, or that expression, the entire expression is being divided by 2, and it equals 6. Okay, in this situation, I have some stuff divided by 2. In order to undo my operations, if I knew what m was, in this case, let's say m was 7. If m was 7, just for sake's purpose, just to help me out here, if this was 7, I'd subtract 1 from it first to get 6, and then divide that amount by 2 to figure out what the answer was. That's if I were doing PEMDAS. But since I don't know what m is, I need to work in reverse order. So since the last thing I was going to do was divide by 2, Now I need to multiply this entire term by 2 so that I can get rid of the denominator. Or you could say I'm multiplying by the reciprocal. Again, this is the multiplicative identity at work. So I would multiply both sides of the equation by 2. Now we have 2 divided by 2. They cancel out and leave 1. And so on the left, I have just the stuff on top. M minus 1 is going to be equal to, now it's important to write it out, the product of 6 and 2 is 12. Sometimes our eyes can play tricks on us and think that, oh, I could look across here and see that 2 is related to 6 by multiplying it by 3. And you think you know the answer, but it's safer to write it out. Next, we want to get m by itself. So let's undo that subtraction with addition. Undo, whatever I do to the left, got to do the same to the right. Equations are jealous like that. So now I've created a zero pair between positive 1 and negative 1. So m comes down by itself, and it must be equal to 12 plus 1, which is 13. The answer, and this would have been a type in or fill in the blank question, you would just write in the box 13. No extra spaces. No, you do not need to write x equals. Nothing like that. Okay, great. That was pretty easy. Let's continue. Number 3, getting my eraser again. Oh, just hit it, Miss Gibbs. Okay, I said hit it. Okay, so let's erase. Let me see if that little technique you guys showed me works. There we go. Okay, so now we have, let me move this out of the way a little bit. An equation is represented by the model below. What is the value of x? Well, the key to your success with these models, as Ms. Gibbs always says, is looking at the key. The key to your success is making sure you study the key, right? And our key tells us that the long rectangular bars represent x, and the small squares represent a number. And in this type of model, we don't have 2 different colors to represent positive and negative. We only have 1 color because we have the sections on our equation mat, if you will, and anything that's at the top is positive. Anything that's in the bottom gray section is going to be negative. So we've got to remember to keep that straight. Okay, so therefore let's first write out the equation that is being modeled. On the top we have 4 x pieces, 1, 2, 3, 4. So that can be represented as 4. Oh, that's a pretty ugly 4, Miss Gibbs. 4x. Well, in the bottom section, in our negative area, we have 1, 2, 3, 4. So this could be represented by 4x minus 4, or if you choose, 4x plus a negative 4. Either way, you'll come out with the same answer if you follow the process. On the right, we have 2 x's. So that's 2x plus, since it's all positive, 1, 2, 3, 4, 5, and 6. 2x plus 6 is modeled on the right. Now, one of those tricky little problems where you have variables on both sides. So, now we must remember the process that Ms. Gibbs shared with you. I love you, and you can call me anytime, but please, darling, don't call me. Got ahead of myself there. Please don't call me. Don't call me after midnight. That's so rude. Okay? Where the D in this acronym represents, you got it, distribute. Going to distribute if I see any parentheses, which I don't. Excuse my abbreviations, okay? Next, we have C, which is representative of combining like terms on each individual side. Well, if I cover up the right side and just focus on the left, I have 4x minus 4. Well, those are unlike terms. They don't look alike, and I cannot put an x term together with a constant. X could be 1, and that would make it 4 minus 4, which would be 0, or x could be 1,000, which would make this 4,000 minus 4, which is a much larger number. You get my drift. So on the right, just the same, there are no like terms. We have unlike terms, so we're good there. So we can cross off the distribution, cross off combining like terms. Neither of those is needed. So now M, the first one, stands for move some things around. We've got to move all of our x terms to one side and all of our constant terms to the other side, so we can get x by itself. Now, I always tell you, move the little guy. It makes it easier, and you should end up with a positive variable term. That should make it a little bit easier as well. So if we move, the little guy is 2x. So let's undo that 2x from each side of the equation. Okay? So we've got 4x minus 2x leaves us 2x's on the left. I'm going to skip around for a bit because I don't have much room. 2x minus 2x on the right cancels out and leaves me 0. That's still a 0 pair. So I have positive 6 on the right, since I'm over here, and negative 4 on the left. I'm going to go ahead and do something else real quick. Since I zeroed out my x's on the right, then that means I need to zero out my constants on the left. So I'm going to go ahead and add 4 to both sides, and therefore my constants will end up on the right. So here we go. Positive 4 and negative 4 cancel each other out over here, so I'm just left with 2x on the left. I've canceled out my x's on the right, and now I have 6 plus 4, which equals 10. Divide both sides by 2, divide by 2, divide by 2, and we find that, let me go over here in this plain space, x, my darlings, equals 5. Easy breezy, beautiful, cover girl. There you go. Easy breezy, lemon squeezy. Okay, so now we have moved and we undid our addition and subtraction. I'm sorry I moved so fast through that. We undid our addition of these constant terms, and then down here we had to undo the multiplication or division, whichever was present, of the x term, the variable term. And there you have it. Easy breezy. I'm going to pause right now and move to, let's see if we have time to go to number 4. Let's do number 4 really quickly. So let me erase. I'm going to use a bigger eraser this time. Clean up. Everybody clean up. Okay. Here we go. Now, for number 4, we have m divided by 9 plus 47. This may take a little bit of time, so I'm going to pause and we'll restart in just a moment. Okay, now